My dear students, welcome to the video Compound Angles Formula. In this video, we are going to learn how to expand some compound angles. We start from the expansion of sine of A plus B. Now, to do that, I first construct a triangle. Now, I label it P here, Q here, R. Now I construct a perpendicular height from R to PQ. I label this angle A and this angle B. So this side will be R. I label this point X. This side lowercase q, this side lowercase p, and it is H. Now, we have learned in O level that in order to find the area of one triangle, given that two sides and included angle, it is half of multiplication of the two adjacent sides and the sine of included angles. Now, area of triangle PQR is equal to half of, I consider sides P, Q, sine of included angle. The angle between P and Q is angle A plus B. Now, we know that area of triangle PQR is equal to the sum of area of triangle PXR plus area of QXR. So the sum of areas of these two triangles. Now, so it is the formula for area of the whole triangle PQR. Now let's find area of triangle PXR. PXR is equal to half of multiplication of QH sine of included angle, which is A. Now area of QXR is equal to half of PH sine of angle B. Now let's express H in terms of angle A and Q. In this triangle, we know that cosine of A is equal to adjacent, which is H over Q. So H will be Q cosine of A, and in the likewise in the right hand side triangle, you have cosine of B is equal to H over P. So H is P cosine of B. Now I write area of the whole triangle, which is half of PQ sine of A plus B is equal to half of area of triangle PXR, which is half of QH sine of A plus half of PH sine of B. Now, so I write the left hand side PQ sine of A plus B is equal to half of Q. Instead of H, I write P cosine of B plus and you have sine of A, I forgot to write, so it is actually H, then sine of A plus half of P instead of H, I put Q cosine of A, Q cosine of A, now sine of B. So as you see here, half can be cancelled out. PQ is the same. We can cancel that out. So what is left is sine of A plus B is equal to, now sine of A cosine of B, sine of A cosine of B plus E plus cosine of A sine of B. This is the expansion of sine of A plus B, sine of A cosine of B times cosine of A sine of B. So I rewrite the first identity, sine of A plus B is equal to sine of A cosine of B plus cosine of A sine of B. It's the first formula. For the second formula, which is sine of A minus B. You know, we learned in AS level trigonometric videos that sine of minus B will be actually negative sine of B. You know, if you use this property, and cosine of negative B is the same as cosine of B, so you can use again the first identity to use to expand this the second compound angle. Then you will obtain sine of A cosine of B minus cosine of A sine of B. Then for the cosine of A plus B, we have this formula, cosine of A cosine of B minus sine of A sine of B. And if you have cosine of A minus B, it will be cosine of A cosine of B plus sine of A sine of B, and fifth one tan of A plus B. You can combine these two formulas. You know that tan is sine over cosine. Then you will obtain this formula, tan of A plus tan of B 1 minus tan of A tan of B, and sixth one, tan of A minus B will be tan of A minus tan of B over 1 plus tan of A tan of B. These are the six actually formula you can use in order to expand these compound angles. Now example, you're supposed to find the exact value of sine of 105, which can be written as sine of 60 plus 45 degree, because we know sine and cosine of both 60 and 45. So if you use the expansion, it is the first identity. It is sine of 60 cosine of 45 plus cosine of 60 sine of 45. So sine of 60 is root 3 over 2, cosine of 45 is root 2 over 2, plus cosine of 60 is half, multiplied by root 2 over 2. So it will be root 3 plus 1 over 2. And for the second part, cosine of 42 cosine of 12. So it is expansion of cosine, because in expansion of cosine of A plus B, we had cosine, cosine minus sine, sine, or plus. So it is plus, so it is cosine of 42 minus 12 actually, which is cosine of 30 which is root 3 over 2. Next example, given that sine of a is 4 over 5 and cosine of b is 5 over 13, where a is obtuse and b is acute. Find the value of sine of a plus b, cosine of a minus b, tan of a minus b. You are given sine of a, so we know that cosine squared of cosine squared of a is equal to 1 minus sine squared of a, which is 1 minus 4 over 5 squared, which is 16 over 25. It will be 9 over 25. So cosine of a is positive negative 3 over 5. But as a is obtuse angle, so cosine is negative in the second quadrant, so it is negative 3 over 5. And for b, sine squared of b will be 1 minus 5 over 13 squared, which is 1 minus 25 over 169. It will be 144 over 169. So sine of b will be positive negative 12 over 13, but b is acute. In the first quadrant, sine and cosine both are positive, so it is positive 12 over 13. Now for part A, sine of a plus b is equal to, I first write expansion, cosine of b plus cosine of a. Sine of b, now I replace sine of a is 4 over 5, cosine of b is 5 over 13 plus cosine of a, which is negative 3 over 5, and sine of b, which is 12 over 13. So if we multiply and simplify, it will become negative 16 over 65. For the second part, cosine of a minus b is equal to cosine of a, cosine of b minus sine of a, sine of b. Now I replace the values. Cosine of a was negative 3 over 5. Cosine of b is 5 over 13 plus sine of a 4 over 5 times 12 over 13, which simplifies to 33 over 65 as part B. And part C, you are supposed to find tan of a minus b. Now to find tan of a minus b, I first find tan of a. Tan of a is sine of a over cosine of a, which is sine of a is 4 over 5 and negative 3 over 5, which is negative 4 over 3, and tan of b is sine of b, which we found 12 over 13, and cosine of b, which is 5 over 13, which is 12 over 5. Now, in order to find tan of a minus b, we use expansion tan of a minus tan of b over 1 plus tan of a tan of b, which is equal to tan of a is minus 4 over 3, then minus tan of b, which is equal to 12 over 5, then 1 plus tan of a, again negative 4 over 3, then 12 over 5. Now which simplifies to 56 over 33 as the final answer to this part. Next example, solve the equation sine of 60 degree minus x is equal to 2 sine of x for x between 0 and 360 degrees. Now I first use the identity we just learned in order to expand this compound angle. So sine of 60 minus x, it will be sine of 60 cosine of x minus cosine of 60 sine of x is equal to 2 sine of x. Sine of 60 is radical 3 over 2 cosine of x minus cosine of 60 is 1 over 2 sine of x is equal to 2 sine of x. Now I transfer negative 2 sine of x, negative 1 over 2 sine of x to the right hand side. It will be root 3 over 2 cosine of x is equal to 2 and a half, which will be 5 over 2 sine of x. Now I can omit these two from both sides, so I divide both sides by cosine of x to simplify, as well as 5. So this 5 cancel out, so sine of x over cosine of x will be tan of x is equal to root 3 over 5. Now you have a basic trigonometric equation. So x will be tan inverse of root 3 over 5, which will give you an answer of 19.1 degree. Then 19.1 plus 180, which is acceptable actually. So it will be 199.1. It is within the interval. If you do subtraction, 19.1 minus 180, it won't give you any acceptable answer. If you add 360, subtract 360, again you won't produce any acceptable results. So the only acceptable results, answers for this equation between 0 and 360 are x is equal to 19.1 and 199.1 degree. Thanks for watching this video.